Imagine in a rainy day, you are standing outside and you don't have any umbrella, you don't have any raincoat, and you will get wet. And if you not take precaution, you will be sick, you will get ill. So the same way, the concrete also behave with the environment. Environment has the immense effect on the human life, the same as to concrete life is also. So if you are not take precaution against the environment, our concrete is also will be sick and it will be deteriorated. And with the civil engineer, it's called the concrete durability. So in today's video, I will discuss about the concrete durability and what is concrete durability, what are the factors affecting concrete durability, and what is the best practice of the concrete durability, and how we can measure the concrete durability. So if you are a civil engineer, quality control engineer, or the construction professional, or just curious to know about the concrete, this channel is for you, and stay tuned until the end so that we will get full information about the concrete durability. Let's open my mind map. This is concrete durability. The first thing is, what is concrete durability? As we have already mentioned the example, that is the example. Now, according to what is the definition? Durability of concrete refer to its ability to resist deterioration and maintain its intended performance and structure integrity over time, especially when exposed to various environmental and chemical conditions. That means how this concrete will behave when the environment is extreme, when the environment is harsh, or when there is a chemical condition is there, how it will withstand and how it will maintain the health of the concrete. That is concrete durability. The same the human also, to protect from the environment, we make raincoat, we make umbrella. In the winter season, we sweater, jacket, everything. Why? We need to protect ourselves from the environment so that we can live longer. The same way, the concrete also needs to be protected from the environment so that it can also live longer and give the structural integrity. So this is what called the concrete durability. The next part is, what is the factor that is affecting durability? There are so many factors that are affecting the concrete durability. First thing, environmental exposure condition, that we have already discussed, that what will be the environmental exposure condition. According to that, the concrete behave and concrete lifespan is deteriorating. So what will be the factor of environmental condition? That is freeze-thaw cycle. What does it mean? It means that if there is any crack or anything in the concrete, the moisture or the water will be penetrate inside the concrete. Now, if the temperature is going below the temperature, 0 degree temperature, or the icing temperature, then this water will be freeze and it will ice, and when it will ice and freeze, the it will expand, and when it will expand, it will affect the concrete. There will be a crack and the concrete lifespans or the concrete health will be deteriorate. So this freeze thaw cycle, how the concrete is behaving or how it is protecting, that is a concrete durability. Then the moisture has the detrimental effect. If it is inside the concrete, then it can corrode the reinforcement, and if it is corrode, then the volume of the reinforcement will be increased. Eventually it will break the concrete or the structure. Then temperature fluctuation, that is also another part. That is the temperature. If it is fluctuate, there will be a temperature difference, and if there is a temperature difference, then there may be a possibility that thermal crack will happen. So this also will affect the concrete health. Then carbonation of concrete. What is carbonation of concrete? That is a very important part. It has that is another subject, but that is also affecting the concrete. That is, what is carbonation of concrete? Carbonation of concrete is a chemical process in which carbon dioxide, that is CO2, from the atmosphere reacts with the calcium hydroxide present in the pore water or the hardened cement paste. This reaction forms calcium carbonate and water as byproduct. Carbonation is typically occurs on the surface of the concrete and penetrates into the interior over time and affecting the composition of concrete. This CO2, that is carbon dioxide, it is harmful for us. The same way it is harmful for the concrete itself. See, it will form the calcium carbonate and it will penetrate the inside the concrete. And when it will penetrate, making the calcium carbonate, that means the composition of the concrete or the cement, it will break and the health of the concrete will be deteriorated. So the CO2 or the carbonation effect has the same thing for the human also. It is dangerous, the same thing also for the concrete, and then exposed to the excessive chemical play. Now if any conditions or the structure is there where the chemical factories or chemical reaction is there, so there will be a chemical in the environment that is also affect the concrete strength. Ultimately it will react with the concrete and it will change the chemical composition of the hardened paste that will deteriorate the concrete strength. So these are the environmental exposure condition which has the effect directly on the concrete durability. Another thing is quality of material. Of course, what is the raw material you are using, that is cement, aggregates, water, and any other cementitious material. And nowadays you are using GGBS, fly ash, etc. So what is the quality of the raw material, that will also decided the durability of the concrete. If we may make the poor quality of raw material or not as per the standard or the requirement or as per the relevant codes, that means we are not providing the food or the intake to the concrete. Then what will happen? If we take the improper food, our stomach will be upset. The same way, if we feed improper food to the concrete, it will be deteriorate. So we need to choose the material as per the requirement. So quality of material also has the effect on concrete durability. The next thing is concrete mix design. See, this is the ultimate things, how we use the mixing ratio, how we will use the admixture. So the mixing ratio also plays a very vital role in the concrete structure, that's concrete strength and the concrete durability. So whenever we are preparing any mix design, we should take care about the durability factor also as well, not only the strength factor, the durability factor also to be considered when you are preparing a mix design. And admixture is good for the concrete. It helps us so many ways, but it also has the effect to the concrete, because it's a foreign material, it's not the actual material of the concrete raw material. So it's a foreign material, how it will react with the concrete over the time, that is also a factor of durability. So whenever we choose the admixture, we need to be very careful. That means it has not the long time effect on the concrete. Then water cement ratio, all we know that water cement ratio is the main thing of a concrete mix design or the concrete. A lower water cement ratio generally result is more durable concrete because it reduces porosity and increase strength. High water cement ratio can lead to greater permeability and reduce durability. So we need to make this water cement ratio optimal, when neither above nor the less. So it should be in optimal, so that whatever the water is required to form a hardened paste or reaction with the cement, the same amount of water we should provide into the concrete, so that there will be no excess water or there will be no less water. So if it is optimal, then there will be less effect on the concrete strength and the durability. And 10 things, air entrant. The inclusion of air entraining admixture helps improve freeze-thaw resistance by creating tiny air bubbles that relieve internal pressure during freezing. So air entrainment is also a factor. If it is there, then whenever this freeze-thaw cycle, then ice is making and expansion is there, so it release the pressure or internal pressure during freeze-thaw cycle. So air entrainment also has the effect on the durability of the concrete. Then the reinforcement corrosion. If reinforcement is corrode, the corrosion of steel reinforcement due to exposure of moisture and chloride ions can significantly reduce the durability. Why? When it is a chemical corrosion is the chemical reaction with the chloride ion and the water, and it react as cathode and anode, and whenever it is react, that expansion of the bar or the volume of the bar has happened, and if it is happen, the stress is developed, and due to the stress, the concrete structure can break. So the concrete reinforcement corrosion also here factor for the durability. That's why we need to be very careful whenever we are making the clear cover. I will discuss these things later, but this clear cover helps to reduce the corrosion of the concrete, corrosion of the steel, which ultimately reduces the concrete durability. Then construction practice. What will be the construction practice? How we will do the construction? That is also a vital part of the durability. Proper construction practice such as adequate curing, consolidation, and finishing techniques are essential at achieving durable concrete. That is, we all know that if you are not do the proper curing, concrete will not get the strength, and if it is not get the strength, the durability will not be achieved. In the long term, it will be, the structure will be deteriorated. So we need to be careful whenever we are doing construction at the site. So whatever mentioned in the spec or the relevant IS code, that the curing, consolidation, and finishing, that to be as per the requirement to maintain the concrete durability or the lifespan. We all do the exercise, that is concrete, our maintenance of our health. The same way we need to maintain the concrete every year, every month, so that the long term structure stability will be there. And then we have already discussed this clear cover. Clear cover also play a vital role. If the water is penetrating or any harmful chemical is penetrating, if it is not penetrating, it is not hit the corrosion reinforcement bar, the corrosion will be not there, the concrete will be safe. But if it is, the clear cover is inadequate, the water and the chemical and the harmful ion will be there, and it will corrode the steel, it will corrode the, it will interact with the concrete composition, and it will deteriorate the concrete structure. So these are the factors which are affecting the concrete durability. The now, how to test the concrete durability? There are different types of tests. All tests we are not doing, but these are the tests we need to perform in order to know the whether our concrete is as per the requirement or not, so that we can ensuring that our concrete will be structure will be stabilized, or the structure integrity will be there as per the lifespan. So first things one, rapid chloride penetration test. All we know, this is the chloride ion. The test measure the ability of concrete to resist the penetration of chloride ions, which can lead to reinforcement corrosion. So the harmful ion is the chloride ion. So we need to protect our concrete for ingress of chloride ion. So these things, how we will know, the how we will test, that is RCPT, or the rapid chloride penetration test. What is the code for this? ASTM C1202 we should follow for the rapid chloride penetration test. Then water absorption test. It measures the water absorption characteristics of concrete, which can indicate the porosity. Why? If the porosity is there, then there is a possibility the moisture will be increased into the concrete, and if it is moisture is increased, there is a chances of the corrosion of the steel, reaction with the concrete component, and the freeze-thaw cycle, which can break the concrete. So this water absorption is very much essential for the concrete durability test, and that should be measured as per ASTM C642. Then electrical resistivity test. The test measure the electrical resistivity of concrete, which is related to its ability to resist chloride ion penetration. Again, how it will again, how it will react with the chloride ion, or how it will resist, that we need to know the electrical resistivity test, and that should be carried out as per ASTM 1760. Then compressive strength of concrete, which primarily used for assessing the strength. These tests can indirectly indicate the quality of durability of concrete. How? Because if the desired strength is not developed in the concrete, that means the load bearing capacity is not there. If the load bearing capacity is not proper, and we are allowing, or we are applying the load, then it will be break, or it will be deteriorated. So that these things also against the durability of the structure. And how we can measure this? STM C39 or 39. Then carbonation depth test. We all know the carbon dioxide is not good for the concrete, so we need to know the carbonation depth test. That means how our concrete is reacting with the carbon dioxide ingress. This test determines the depth of carbonation penetration into the concrete surface. So again, how much it will penetrate inside the concrete, that we need to know. Again, the carbonation depth test, which is also required to know the concrete durability. That is by ASTM C567 is the code we can measure the carbonation depth test. Then water absorption, that we have already discussed. Then surface sulfate resistance test. These sulfate resistance test, they assure the resistance of sulfate attack. If it is sulfate attack, again it will react with the concrete component, and the component will be reacting, and these things will also make concrete deteriorate, and the ultimately eventually it will break the structural integrity, and the lifespan will be concrete will be the resistance. So this sulfate or resistance test also you need to know in order to ensure the concrete durability. ASTM C1012 is the code. Then alkali silica resistance test, that ASR test. This test evaluate the potential for alkali silica reaction, a chemical reaction that can cause cracking and deterioration of concrete. That these things, again it will be crack, and if there is a crack, the water, chloride ion, sulfate ion, everything will be penetrated inside the concrete. And if it is penetrated, is a foreign material, is a harmful, just like virus and bacteria for our health. If the virus and bacteria penetrate inside our health will be sick. So the same way, if it is inside into the concrete, that is sulfate and the resistance or the chloride or the water or the moisture, then the concrete strength or the concrete health will also be in risk. So that we need to protect the concrete from the attack of sulfate, alkali and silica. That's why we need to know the what is the alkali silica reaction against the concrete. So, and according to know, we can measure or we can take the reaction, and this will be tested as per ASTM C1260 and C1567. And then again, freeze-thaw cycle test, that I already discussed. What is freeze-thaw cycle? The the water will penetrate, and if the temperature is below the icing temperature, it will become ice, and it will increase the volume, and it will causes the crack of the concrete. So how we can measure? As per ASTM C666 is the measuring code. Accordingly, we can measure the concrete ability to resistance to the freeze-thaw reaction when in the environment. So these are the durability tests. So in this way, we can test the durability. The next thing is, what is the best practice? Now we know that what is durability, and what is the factor affecting durability, and how we can test the durability at the site. Now we need to know what is the best practice, because we need to do the concrete. Now we have already known what is good for our health, and what is how to test that one, everything. Now we need to protect ourselves to be healthy and to live a long life. Now we need to do the best practice at the site, so that the concrete can also be healthy and long lifespan. So what can we do this? That's proper mix design. Again and again, the first thing, this proper mix design. What will be the ratio? Is the same like for our human bodies. What the ratio of protein, vitamin, carbohydrate. These things will be in a proper balance. If one thing is more, another thing is less, our health will not be the healthy. The same way, what is the raw material? That is the what is the cement, aggregate, cement, sand, water, that should be in the proper proportion, so that the concrete can gain full strength and durability can be ensured. Then quality of material, again the raw material. What we need to be fit ourselves, we should take that one only. The same way, what is need to be fit the concrete or concrete make healthy, that also need to be choose or need to be considered. So the quality of the raw material to be as per the standard or as per the relevant codes, that we need to ensure whenever we are doing a concrete and whenever we are choosing the raw material. Then the water cement ratio. So water cement ratio also you have already discussed, should be minimum optimal, neither more or neither the less, so that the cement and the water can react together and make a hardened paste, and there will be no more water inside the concrete. Then admixture is a foreign material, so admixture quality and the admixture quantity to be measured as per the requirement. Then the proper curing, reinforcement protection, regular maintenance. See, maintenance also required. We are doing our regular health checkup, we are doing regular exercise, we are taking food every day. What this we need to maintain our life regularly so that we can live longer. The same way we need to do the regular maintenance of the concrete. We need to check, is there anything found in the concrete that which is not good for the concrete. Immediately we need to do the rectification. If we find any crack, we need to check periodically. That if we find any crack, immediately we need to rectify the crack. So we need to maintain the regular maintenance sequence or the procedure so that the concrete can be integrate with the structure and should be the long lifespan. And then environmental consideration. What is the environmental condition when the rainy season, when the winter season, when the hot summer? Accordingly, we have to maintain the concrete and we have to protect the concrete. And then quality control. See, quality control is everything. So from choosing the material, raw material, making the mixing design, concrete placing, concrete making, then concrete curing, concrete testing, and then concrete maintenance. Everything to be as per the requirement of the relevant codes and standard to ensure the concrete durability and the structure integrity. So this thing is very much important. We should not neglect any part of the concrete durability, because it will give you the longer lifespan of the concrete. We all need to live longer. The same way concrete also need to live longer. But for that we need to take proper precaution from the beginning to the maintenance stage so that the concrete can live longer. So these things about the concrete durability, what is concrete durability, what is the factor affecting, what is the best practice, and how we can measure the concrete durability. I hope I cover everything, and I think you have find it useful and you are enjoying this journey. So kindly subscribe my channel and hit the bell icon, and I'm waiting for your valuable feedback so that from your feedback everybody can benefit. And if you want to know more about concrete or the construction or the quality control, please let me know so that I will come also with the more content like this. And again, thank you very much for watching me.